Good afternoon, everyone. Welcome to UTA Planetarium's next live star stream. My name is Levent Gürdemir. I'm UTA astronomer and planetarium director. Today, we are going to talk about a special topic, Mars. And why we are going to talk about Mars? Because next week, some information, some news about the Mars will be all over the place, and we'll even have a special star stream for this event because next NASA mission called Mars Perseverance is going to land on the planet's surface next week. So today we wanted to talk about a little bit why Mars is important and why it is our best interest to look for the signs of life other than Earth. So, well, the life as we know it on Earth, great. So you can have your boat and ride, and this is a great planet, right? And we have plenty of air to breathe, and there's a lot of factors bring the life to this planet. I know it may feel miserable nowadays, and you may argue that, well, the life is not great on Earth, but I would say no, it is still great. So the plenty of water and plenty of air, and particularly water in a liquid form, important for life. So if we are looking at life or signs of life outside of our planet, then we need to find out whether these two conditions can be satisfied, like if we can find liquid water and just enough temperature range to survive. So if we look at the planet, so this is an interesting chart. It is called, it is showing the habitable zones. The habitable zone means the zone around a star that we can expect life for an Earth-sized planet. And apparently, I mean, this is the distance from the star. So we are going to put our sun right over here. And apparently for that two planets, there is too much heating power. So water evaporate quickly. The planets are too hot. So the life, at least in the solar system, for an Earth-like planet, we are not expecting life on these planets. So how about on the other side? So on the other side, there are other problems. There is not much heating power on these two and beyond. Plus, those are gas giant planets. In a gas giant planets, we do not expect any life anyway. Why? Because, well, for the life, we just don't live in the shell of gas. So we need just some like land, some like a medium, like liquid, etc. So that brings the Mars in question, because the Mars is also making the edge of habitable zone in the solar system. Also, today we know we have a big evidence that Mars had water in the past sometime. So if we add water to Mars' surface, Mars will probably look like this. And why like this? Because there's a big valley covering the almost entire northern hemisphere of Mars, and the south part of the planet is more like filled with mountains and high places. So the southern Mars is going to look like still a desert, and the northern part will probably feature big oceans or seas.
But this is just to make sure the viewers know, this is not an accurate photo of Mars now, right? This is an artist rendition of what it looked like with water.
Yes, based on the terrain of the Mars we know now. If we add water, it will feel this way.
Gosh, can you imagine a planet like that just that has water, liquid, and beaches? I'm just like Earth.
Well, that's what we were trying to find and wishing to find, right, over decades, because we always like to find a place that maybe we can travel someday. And of course, if the conditions on Earth goes bad, right? So we are trying to look for a spare one. But unfortunately, so far in the solar system, there is no spare to Earth we could find.
Definitely. Mars would be a great place, though, if we had. It's our backup. We'd have some work to do, no doubt about that. Definitely no water there. We had some questions getting a little ahead of our talk. It looks like hello Brexton and hello Janet. We're gonna go ahead and answer Brexton's question here if you have time, Levent. Do they have info on what is in the core of Mars? 2 question marks. Very interested.
Well, the core, I would expect it would be very similar to Earth's core, but there are some differences, of course, because the Mars have no magnetic field or very weak magnetic field, so there are some differences. But from the interior of Mars, we don't know a lot, so that's why the current missions that I will explain is going to look further deep on the surface of Mars. So I would like to talk about a little bit history of after that became to our attention that well, there may be life on this planet. So let's look at all the attempts to explore and how we explored it. All right. So the exploration attempts started, believe or not, in the early 60s. So between 1960 and 1962, the Soviet Union, today we know as Russia, designed 4 flyby and 1 lander missions to the surface of the planet. And unfortunately, they all failed to launch. Well, it takes a lot of attempts to do it right sometimes. And even NASA spacecraft, the first spacecraft they tried to send to Mars, failed. That was Mariner 3. And then later that year, they designed and sent another spacecraft called Mariner 4. Mariner 4 is behind me. This is a great satellite, and it is designed to just a flyby mission. The flyby means you just pass near the planet once, and you just go back in the space until it disappears. So this spacecraft is very interesting for me because it had an antenna to communicate with Earth, and it is designed to take pictures. So when it actually it was near the planet, it took 21 pictures from the planet. So those pictures are important because they were the first close-up pictures of Mars. So
what kind of cameras did they? I mean, do you know about the cameras they had on there?
Oh yeah, the camera was very interesting one because like it was the camera that converted all the lights into a digital format, pretty much like our cell phone cameras today, and most of the cameras we use today
this
are
was
digital.
Before digital, like a true digital cameras, right? DSLRs?
Oh, yes, well before. We are talking about year 1964. And the camera, after the camera captured the image, that was a black and white image, so it was converted into digital numbers, just like the digital cameras we use today, and they were transmitted to Earth using this antenna. For each picture, it took 6 hours of transmission. Can you believe that? For each picture, you waited 6 hours. And all the images on the spacecraft were written on this type of tape recorder. This is not a compact disc, this is a tape recorder. So this is a big wheel, and there is a big roll of film, magnetic tape, and all the numbers are written on that magnetic tape. So they are transmitted to Earth, and guess what happens afterwards? So the computers of NASA centers processes these numbers to reconstruct the image exactly the same way as it was seen by the camera. But the computers of that day,
some early pictures. This is the clearest picture taken by that flyby mission from Mariner 4.
Yeah, nothing comparable today's pictures. I will show the today's pictures
kind of embarrassing,
too.
actually.
But imagine the computing power. So each image, the numbers came to the NASA centers, and the computers processed the images. How long for the computers that it take to process the images? Very, very long time. So the engineers got bored while the computers were processing the first image. just for verification purposes, they actually took the numbers came from the satellite communication and the hand-drawn, based on those numbers, hand-drawn the image before the computers processed the first one. Can you show the hand-drawn image by the engineers?
Yeah, absolutely. Just to pop this up here, this is actually the first picture they ever got completed. But the engineers, as you were saying, were not patient enough. And so as they were not being very patient, they decided to draw it. This is just totally ridiculous. Here we go. Let's show it.
Yes, this is the hand-drawn picture by the engineers based on the numbers came from the spacecraft. Again, they finished the drawing before the computers processed it for the first one.
All right,
it was pretty close.
We got a question from Brexton again. A very good question. I really like it. So the question is, could they send digging equipment to dig deeper into Mars' surface? And definitely.
Yes, this is actually the some of the landers doing. They have like the diggers, all the machinery to dig the soil and analyze the deep inside of the surface.
Yeah, NASA's InSight lander that was on the surface of the planet Mars had a little drill, a little mole they called it, that was going to try to drill pretty deep to study the core and to study things like Mars quakes, not earthquakes, but Mars quakes. Unfortunately, just recently, last year, they I guess called that drill no longer working, so it is out of service, unfortunately.
So let's look at the successor missions. So after Mariner 4, NASA sent different orbiters and flyby missions, but I'm going to take our attention to mostly landers. So first successful lander was designed and sent by Soviet Union again. That was back in 1971. Long time ago, or like 40 years ago. So Mars 2 was carried. It was a small, actually, robot, small rover, carried on in this spacecraft, and it successfully found Mars, landed on Mars, deployed these panels, and the spacecraft was going to release the rover, and the rover was going to operate on the Mars surface.
Here's our cute little rover.
Look at that. This rover, it looks like nothing today. I mean, if you probably find it on the street, you wouldn't just pick it up because it's not interesting at all. It has like.
Does it have wheels?
Yeah,
what is going on?
They call it ski wheels. So it actually pushes itself like the ski motion. So and it, I think this is
like is it just slide off the rover, or does it get a sail or something to ski around? How does it move?
I don't know how it is designed, but I think this looks like an electric motor on the top, and maybe communication antenna or something. But certainly, I mean, look, it's the basic off rover, but we are talking about 40 years ago. What do you expect, Jim? 40 years ago.
Yeah, I guess.
This actually landed on the surface of Mars. That's the important thing. So, but we don't know if that rover ever moved from its location, from its from the lander.
Oh yeah, it broke like 3 seconds in. Or
yeah, because the problem is spacecraft lost the communication. Something broke in the spacecraft itself. So we lost the communication, and we have no idea how did the rover performed. So that was a bummer. But anyway, they designed another one. They designed another Mars 3 lander. It was successful. But let's move on. So in 1975, NASA sent Viking 1 lander, and later then Viking 2 lander. So those were similar lander missions. They did nothing but landing on the surface of Mars. They did not move around, but they had like the panoramic cameras and communication satellite, as you see here. And when they landed, I think they sent the first spectacular pictures to Earth.
I got it. I got
Not
it.
the
Here we
first
go.
pictures, but first spectacular pictures, because this gave us the idea how the Mars terrain was.
So these weren't color cameras, I'm assuming, right?
Yes, they were not colored cameras.
This looks so much more. I don't. Maybe it's weird, but it looks so much more real than the photos we see that were taken by Opportunity or Curiosity. I don't know if this is just in particular a super high resolution image or what, but something seems so much more surreal about it.
I think the shadows and all the great contrast of black and white makes it spectacular, because it gives a deep feeling. So it's like a 3D picture. And this is the leg of the lander. I don't know why you would get a big portion of the view covered by your leg, because I mean every pixel in or every inch in this picture is important, and I would just move the camera away from the part of the part of the robot, because we know how it looks. We are not interested in how the spacecraft or how the lander looks.
Wait, actually, I think I can adjust that image. I got a little bit more on that. Give me just a second.
Okay,
Let's
yeah.
see what I can do. We got more of it. That's still not very much, though. That's as good as it's gonna get. So a few more rocks.
Yeah, still I see the part of the spacecraft here, so that's unfortunate.
Okay,
all right.
actually, we have a cool picture that needs to be shown to everyone.
Yes, I've seen better
first
pictures.
Sunset.
Oh, this is sunset.
Maybe sunrise. I don't know. Who's to know?
I think it's sunset. Yeah, the landers also watched and the photographed the sunset on Mars. I don't know if they were on a romantic occasion or I don't know. Maybe it was the Valentine's Day night that the robot was feeling lonely, and anyway, they wanted to watch
Important point, Levant.
sunset.
We should tell people we are doing something on Sunday. If you're looking for something romantic to do, or not romantic, maybe just fun, this Sunday on the 14th at 6 p.m., Levant will be back, and he said he's going to wear a tuxedo, I think. What color did you say? Well, you said it was white tuxedo?
I did not say anything like that.
Well, you guys should hold him to it. But
well, the thing is, I may spoil the spirit of the Valentine's Day if you let me do the show.
wait, you're doing the show?
Because if I'm asked, who is doing the show, Jim?
It's not. I mean, it's not me. I'm not doing the show.
Okay, then
I've got
I'm doing the
buttons to
show.
press.
And I'm okay. I will be here at the Valentine's. How about it? I will be here at the Valentine's Day evening to give you a bunch of unnecessary information about space.
Oh, yeah. So see us Sunday, the 14th at 6.
Get your Valentine, and certainly the show is BYOB, and just be here on the Facebook channel, and then join us with the conversation in the chat window, and here we can talk about.
Wait,
if
you said BYOB, that definitely stands for Bring Your Own Blankets, right?
oh, of course.
Okay, good. Yeah, just checking.
Why do you think otherwise? I don't know.
I could have stood for something else, like basketballs or boomerang.
Okay, the
Okay.
show is for adults only, okay? I mean, we are not going to show any rated content here, but the show is certainly for grown-ups, because we will talk about just, romantic occasions and some stories about Venus and things like that. So, yeah, be here on Sunday evening.
Okay, we have a really good question from Richard Johnson, and he asks, the sunset looks bluish with 3 question marks. So we got 2 from Brexton. This one is really, they want to know the answer to this question.
Hi, Brexton. Well, this one may not represent the right color, because some other pictures I've seen in different sources, the color was little different. It wasn't blue. But if the blue was the true color, I would say the Mars air is so dusty, and dust refracts light, and refracted light can appear in different colors. That's why during the sunset on Earth, we see the tones of orange and red and even sometimes green during the sunset, because the light refracts by the air molecules. So dust refracts the light even further, and even can show us bluish colors if that's the real color. Great questions. And
All right, this cool colored picture from, this is actually not Viking 1, this is Viking 2, I think. But the colors look strange in this picture, don't they?
well, it looks like, yes, it may be just an enhanced picture. And or
like a colorized,
what we call today photoshopped picture. I mean, it's not fake picture, but it is just improved by just vividing the colors and increasing the contrast, etc. So this part looks more realistic, but yeah, this looks like an enhanced. And I've seen a lot of pictures, the black and white pictures of the old times. So they do wonderful photo processing, and it turns out to a great colorful picture. So let's talk about Pathfinder. So that was in 1970s, and now we are coming to 1996, more modern times. So there's another lander designed by NASA, JPL, Jet Propulsion Laboratory, it stands for. And this lander is carrying, the name of the lander is Pathfinder. It is carrying this rover called Sojourner. Well, Sojourner is a small remote controlled rover, and the Pathfinder lands on the surface of the planet for the first time using airbags. Yes, they just literally pretty much like how the today's mail carriers treat your packages. They just drop them off your porch. The same way, I mean, not all of them doing that, of course. But it lands on the surface of the Mars in airbags. Okay.
I tried to find the video of it. I saw a clip somewhere on the internet, but I couldn't find a video that we could get permission to use. But this thing really, like Levent said, it just bounced like a super ball off the surface of Mars until it stopped moving.
Interesting thing about the rover, the Sojourner rover I found, is it had amazing computer on board. So let me read the specs of the computer.
Yeah, this was the first rover, right?
Yes.
Working rover.
Yes, that's the first working rover, and it traveled 100 meters, roughly about 300 feet. So the embedded computer on board of this rover was based 2 megahertz Intel 8085 processor. So can you imagine 2 megahertz? What can you run with 2 megahertz CPU today? Certainly it cannot run your cell phone. Maybe pocket calculator, but nothing more than that.
I bet it could run Notepad.
So it had 512 kilobyte of RAM, which you cannot fit in even a Word document today. And 176 kilobyte of flash memory. It's a solid state storage. So
that's high tech.
That's a tiny storage for nowadays, but that was in 1996. So that was the technology that we could put in a rover. Today we can do a lot better.
All right, I have to cut in. This is important, and the people need to know that in this picture next to Levent, right next to his head, there's a big rock.
Mm-hmm.
And for some reason, NASA or the people surrounding the mission decided to name a handful of these rocks. So the one right next to your head, if you can point to that one, Levent, this is called the Yogi Rock. And then this one, if you could point down here to this one, Levent. This one is called what did they say, Levent? Was it? It's called Barnacle Bill. They named the rock Barnacle Bill. I can't imagine.
But I don't get the idea entirely why you would name a rock on the surface of Mars. We won't even be able to recognize or even find it if we go to the Mars surface today. But this one maybe because probably the rover is still near it. So this rover, it operated less than it operated less than 3 months. So that was the first rover experiment on the surface of Mars. So let's quickly actually move the further.
Next mission.
Yes, next mission. Spirit and Opportunity. In 2004, NASA decided to land 2 rovers on the surface of planets. So one to be landing on each the opposite side. So the rovers landed in the opposite side. Spirit looked like this. Operated until 2010. Unfortunately, it got stuck somewhere on the planet. That was a sand trap that it got stuck, and it was unable to just direct their solar panels to the sun, so they couldn't charge the battery, and it died. The Opportunity looked very similarly to the Spirit, and it ceased the communication in 2018. So it operated for a long time. These rovers were actually designed to operate only 3 months. So the Spirit operated 6 years, and Opportunity operated actually 14 years, well beyond their design limits or design time. So here are the comparison, nice comparison of the rovers. This is Sojourner rover, landed with Pathfinder. This is either Spirit or Opportunity, one or the other. They are identical, but you can just see the size difference. And here is the next rover.
That's Curiosity.
We'll be talking about Curiosity, yes. And Curiosity this is about maybe a sedan car size rover. All right, let's talk about Curiosity. Landed on Mars in 2012 and still going on. That is amazing. So it was designed only for 2 years of operation. So this one is also well beyond the operational window. This one has the ability to, using this arm, dig in the ground and grab like part of the soil and put it on board laboratory, analyze it, and just send the results. It does all the job for you on the surface of the planet. And it traveled around 45 kilometers, so roughly about 27 miles on the surface of the planet. So that's a great distance. So if you think about it, that's roughly the distance of between maybe Dallas and Fort Worth.
Here we can compare to the size of their wheels. This is a neat graphic.
Yes, Sojourner, Spirit, and Opportunity, Curiosity. So wheels are getting bigger and bigger as we send more and more rovers on the surface. So let's talk about quickly what is next. In 2021, NASA launched another spacecraft carrying the next rover called Perseverance. So the Perseverance is about the size of Curiosity, but the spacecraft also carries a helicopter drone that will be tested for the first time on a different planet. If you like flying drones on this planet, so imagine NASA will be flying drones on a different planet for the first time.
Here's a comparison of the two. I mean, they look nearly the same.
Yes, very
Curiosity
identical.
on his left, and Mars 2020, or as we so affectionately call it, Perseverance on his right.
Mm-hmm. Yes. The landing sequence is very interesting. So the Mars have, even it's a thin air, Mars have air. So aircraft cannot just directly go on the surface of the planet. So it has to maneuver like our spacecrafts during re-entry. So it is designed to do the entry maneuver and then launch a parachute to slow down the spacecraft at certain speed. And when the spacecraft slows down sufficiently, it deploys its propulsion jet engines. So jet engines further slow down the spacecraft, and finally there's a crane bringing down the spacecraft on the Martian surface, and then the spacecraft itself releases the crane and then flies away and lands on different place. So why it doesn't land on top of the lander? Well, because these jets are actually can make a big crater for the rover itself, and rover actually may get stuck in that crater. So they don't want that. They just throw the spacecraft to somewhere else. So this is a very interesting entry. It was tried in the Curiosity. Curiosity landed the same way too, and that's the next generation of landing system. So finally they got rid of airbags because airbags carried even more risk to landers.
Awesome.
Next week, we are going to talk about the Perseverance. We are not going to do the live star stream on Wednesday, but we'll do it on Thursday. Why? Because Perseverance is landing on Wednesday, and we would like to show that landing to you by connecting NASA. So I hope you will be here next week again with us. And let's see. Will you be tuning to our live coverage next week?
We have everybody says that they're going to come. This is great news. Yeah, we just drop a poll down here and hope you guys don't forget about it.
All right, great. So see you next week.
All right. Thank you so much, everybody.